All right, Chapter 13, Quasi-experiments and small n designs, small sample size designs. I'll start out with just a few examples from the textbook of quasi-experiments. So this is studying the percentage of individuals who consent to organ donation in different countries. The ones in red have an opt-in policy, so you have to take some action to opt in. To become an organ donor, you have to check a box. Or they have an opt-out policy, meaning that by default you're an organ donor unless you express, unless you decide to opt out and say you don't want to do it. And you can see there's a much higher percentage who consent to organ donation if the default is to opt in, or if the default is organ donation, so an opt-out policy, presumed consent. The next study, this is comparing self-esteem over time, a longitudinal study of people who underwent cosmetic surgery and people who only considered it but then opted or did not go through the surgery. And you can see that there's some separation. Those who did the surgery do have higher self-esteem and some higher scores on related measures as well. Okay. This is assessing the effect of a show that was on Netflix, 13 Reasons Why, which depicted suicide. They wanted to see if that increased suicide rates. Okay, so they first wanted to measure whether there was an increase in mentions of the show or when there was a maximum, and they found that was in April 2017. And then they looked at suicide rates during April of 2017. Okay. And they saw that there was a higher than predicted number based on historical data. Okay. So quasi-experiments, you can see that these are a little bit different than other ones that, controlled experiments that take place in a lab or whatever. They still have some kind of IV that's often manipulated in some way, but you don't have full control over it. So there's an intervention, whether it's the TV show or the surgery or the policy, the questionnaire that participants are presented with to opt in or opt out, but there's not full control over that. Okay? And sometimes there's good reasons for why that's the case. So we'll talk about what you can learn from these, some caveats to keep in mind. Oops. So internal validity, there are potentially selection effects that can threaten the internal validity of these kinds of studies. You're not randomly assigning participants usually. They're just kind of there. So if there's systematic variation between the two groups, then that can be an issue. Having a pre-test and post-test design can help, or you can take into account any differences between the groups at baseline and then just look at the difference, from pre to post. An alternative that is not really a quasi-experiment is a waitlist design. That would be a real experiment where you can randomly assign people to either to receive the intervention or to be on a waitlist. This is a pretty common technique for investigating different types of therapy, for example, where people are just tracked over time while they're waiting for the therapy to begin, and that can help you to control for things like maturation threats, history threats. It doesn't control for everything, of course. It doesn't control for a placebo effect and demand characteristics, things like that. But design confounds, just like with regular experiments, there can be other co-occurring conditions that differ between the two groups beyond just the IV, especially because these tend to be less controlled situations. That can be the case, for example, countries with opt-in versus opt-out policies. There may be other important differences between those two countries, like differences between the Netherlands and England, for example, besides only that policy, and that could influence that data, or the DV. Okay, so maturation threats can exist as well, but a comparison group can help you to take care of this. Here's another example, or history threats. This is more relevant to history threats. So comparison groups can help with that too. Sometimes those are unknown. So if you have a replication study that you can do. So another study referenced in the textbook is about pain clinic laws, adjustments to how pain clinics can disperse as far as opioids, and seeing how that affects opioid deaths. And this was comparing the study reference was comparing 2 states in particular, Florida with North Carolina. But this is comparing multiple states just to see if those with pain clinic laws and those without, if that's the effect they observed held across multiple states. So there could have been in that original study, some historical event that happened in Florida but didn't happen in North Carolina. But it would be unlikely to be an issue if you see the same pattern across many states as you would see here in this figure. Okay. Regression to the mean, attrition threats, testing and instrumentation threats, observer bias, demand characteristics, placebo effects. These are all relevant. You can often look at the data to determine if regression to the mean is an issue. For example, this occurs if you have some extreme at the beginning, right, and then it regresses to the mean, and that's the only reason for the differences that you see between pre and post. But if you have a comparison group, then you can make more of a determination as to whether one group had an extreme measurement at the beginning. Attrition threats, these can be an issue if they're systematic, but a comparison group can also help with this. Testing and instrumentation threats, again, comparison groups can help with this, but anytime you have multiple measurements taken, that's something that you need to consider. Observer bias, demand characteristics, placebo effects. Placebo effects are really kind of the biggest thing that's threatening the internal validity of this study here, where this difference, you can't really say that it isn't due to the placebo effects, because people who had the surgery knew that they were having it, and they expected it to have some kind of effect on their self-esteem, whereas those who did not have the procedure didn't expect that, and they maybe even felt worse about their self-esteem and knew that they hadn't done something that they could have done. So why do quasi-experiments, and what considerations need to be made? What things are prioritized? So these are often real-world opportunities, and that helps to boost your external validity. As you can see from the examples, this is like more applied out in the real world, not controlled in a laboratory. So you may sacrifice some internal validity, but they often have better external validity. Ethics, sometimes you can't ethically randomly assign people to, you can't assign people to live in the Netherlands or live in England and compare the two, or randomly assign people to receive surgery or not. So that's often a reason why these need to be quasi-experiments instead of real ones. Construct validity, of course, and statistical validity are always good to think about when interrogating these results. Were the variables measured properly captured? Do they really get a good handle on what you're trying to study? And statistical validity, thinking about things like replicability and precision. Now, these may kind of sound like correlational studies. Correlational studies both may use independent groups designs, neither use random assignment, and neither have truly manipulated variables that you have full control over. But with a correlational study, typically, it's just if you have people selected, then you measure two variables and the relationship between them. Whereas a quasi-experiment, it's often a more intentional selection of participants, and maybe they're tracked over time instead of just cross-sectionally. And then the comparison group is often very important to how that is selected. So they may look kind of similar, but they have some key differences, but also some overlap. So small N designs, these may be true experiments. They're just conducted on a small sample, just a few people or sometimes just one, which are called case studies. One of the most famous case studies in psychology is the case of H.M. He had surgery removing sections of his temporal lobes on both sides to relieve epilepsy, and as a result, had severe amnesia, wasn't really able to form new memories of particular kinds for the rest of his life. There were some kinds of memories that he could still form, but so we learned a lot about the role of the hippocampus in memory consolidation from HM, and the findings from research on him have been replicated in other studies. Okay. These can allow for some conclusions, but they need to be carefully controlled studies, often compared to case-matched control subjects. There are some disadvantages, though. HM, for example, had been taking epilepsy anticonvulsants that actually damaged his brain, damaged his cerebellum. So it's hard to conclude that these need to be these results need to be interpreted with the caveat that HM's brain was different from the typical person, and when you have a sample size of just one, then that's something you have to deal with. So there's pretty poor external validity here. So this needs to be just kind of a starting point for generalizing to other individuals that have no damage to the hippocampus or the cerebellum, damage to the cerebellum alone, for example, or damage to only the hippocampus and not the cerebellum, okay, just to see if the findings hold up. Stable baseline designs. This may kind of look like a really bad experiment design like we saw in a previous chapter, but there's a key difference here. Okay, so this is words recalled, and you can see there are 5 measurements measured before, and then there's some intervention, a treatment, and then it's measured afterwards. Okay, so many of these internal validity threats are ruled out by the fact that you have this stable baseline. So, for example, regression threats, if you only measured this once, then you couldn't say that that was the true baseline, or if it was just an extremely low measurement that then regressed to the mean, extremely low measurement that then regressed to the mean afterwards. But since you can see that it's stable at first, then you can more confidently conclude that this change was caused by the intervention that happened here. Similar to this is a multiple baseline design, where you can rule out things like history threats because you have multiple stable baselines, or a stable baseline for each individual, but they're collected at different times, so that if if they were all done at the same time, there could be some event that may have caused an increase at the same time, or caused a change in the DV at the same time as the intervention. But since the intervention onset is staggered, you can rule that out. Okay. Reversal design is also similar, except you're kind of going to and from baseline. You're kind of switching, like you're switching a light switch on and off. And this, you can pretty well nail down a causal claim here, just like you can nail down, flipping a switch causes the lights to turn on and off. Here you got the baseline treatment, it goes down, goes back up. When the treatment's not in place, and then goes back down, etc. over time. So it seems to really reliably follow the presence or absence of the treatment. Okay. Some other examples of small n designs. You have Ebbinghaus, who did some studies on himself, his ability to remember random syllables, and how he forgot a lot of them over time. There's a steep forgetting curve. Piaget did a lot of foundational research on child development on his own kids, and that's been replicated since and held up pretty well. The internal validity of these studies can be very high if the study is designed very carefully with a lot of controls in place. External validity, of course, can be problematic as a result, and because you're only dealing with a sample size of 1, it's hard to generalize to the population when you have such a small sample. And so more studies would need to be done in order to confirm these findings, to see if they generalize. Construct validity and statistical validity, of course, are considerations, but statistical validity, it depends. Sometimes this isn't really much of a consideration. I mean, it could be if you're making many measurements, and taking an average that way, for example. But